All right, let's get into it. Before we tackle math's biggest problems, we gotta set up base camp. See, it's not just about finding answers. We have to agree on why we can trust a prediction at all. So before we start that climb, we absolutely have to check our gear, the fundamental rules of reality. Let's start with a really simple idea. To measure anything, you need a tweezer, 2 reference points. But what happens when you try to measure something ridiculously small? Well, the tweezer itself starts to break. That breaking point, that's the Planck length. It's a hard limit where measurement just hits a wall. And here's the thing. It's not a bug, it's a feature. It's the universe's slack, its fundamental pixel size. This whole limit is governed by a rule called the Sprague ratio. For a measurement to be valid, it's gotta be greater than 1. If it drops below 1, you break causality. That means an effect could happen before its cause. No way. So Planck gives us a hard limit on scale, but what about shape? Is there a limit there too? This brings us to a huge question in topology, famously known as the Poincare conjecture, a real head-scratcher. And after nearly a century, the brilliant Grigori Perelman proved it. The answer was a resounding yes. And his proof showed something incredible. If you combined boundedness with symmetry, you literally force a specific structure. So, how do we connect the universe's tiniest pixel size with its required fundamental shape? Well, we can visualize it with a really powerful metaphor, the sphere in cube. The sphere is all of a sudden infinite possibility. And the cube? That's the box we use to actually measure it. To trap all that infinite potential, you need exactly 6 constraints, right? Like the 6 faces of a cube. And this isn't just a neat trick, it's a topological necessity. It absolutely has to be this way in 3D space. So get this, any prediction is basically us forcing infinite potential onto a finite, measurable grid. We combine Planck's scale with Perelman's shape, and voila! We get the 3 rules we need for our journey. We call it the trilemma principle. It's boundedness, symmetry, and conservation. Let's break them down real quick. First, boundedness. That's our cube. Every system needs a box. You can't just let things run on forever. Next is symmetry, our mirror. The rules inside that box have to be consistent and apply equally everywhere. And finally, conservation. That's the ledger. Nothing just appears or disappears. The books always have to balance. So our gear is checked, our rules are set. The real question is, are we ready for the climb?